dock water allowance, that is a DWA? Well, first let me define what is a dock water. We know that the freshwater density is 1 ton per cubic meter, or a relative density is 1, and also the salt water is having 1.025 ton per cubic meter, and the relative density of salt water is 1.025. Well, any water which lies between these two limits is called dock water. Let me repeat it. So any water which is having the density between 1 and 1.025 will be called as a dock water. Now let us understand this concept that a vessel can be loaded up to summer load line, that is the upper edge of the summer load line. I think just let me just mark here upper edge of the summer load line, and we say that the density is 1.025. However, we also know that this is F mark. In fresh water we can load up to F mark, and here the density is 1. So we know the difference from 1 to 1.025 from here to here. If the vessel is say somewhere here and goes down to this S mark, so this vertical distance is called freshwater allowance. Since the dock water density is between 1 and 1.025, so we can say the density is somewhere here, and if the vessel was in dock water, the vessel will be somewhere here at the green line, and when it comes to the salt water, she comes to this level, she rises and it comes to this level, and this distance is called dock water allowance. Well, we can understand that dock water allowance is a fraction of freshwater allowance. Why? Because this is a freshwater allowance. This one is a freshwater allowance. So the dock water allowance is a fraction of a freshwater allowance. Now we can define dock water allowance as this is the number of millimeters required to change the ship's main draft when vessel goes from salt water to dock water, and vice versa when loaded up to summer displacement. Well, in case of fresh water, it was from salt water to fresh water. Freshwater allowance. So in case of freshwater allowance, vessel goes from salt water to fresh water. The change in the draft is called freshwater allowance. However, in case of dock water allowance, when the vessel goes from salt water to dock water and vice versa, the change in the mean draft is called dock water allowance. Now let us revise this concept once again. So vessel is in salt water here, and here the density is fresh water. So if the vessel was in fresh water like this and comes to salt water, this distance is freshwater allowance. Well, as the dock water density is between 1 and 1.025, so let me just mark here, this is the dock water density. So if the vessel was floating in dock water and she comes to salt water like this, so this distance is going to be dock water allowance. So we can say that dock water allowance is a fraction of fresh water allowance. Well, this helps us to calculate the draft. Say for example, here if the difference between, just let me scroll it up, if the difference between fresh water and salt water is this one, we have freshwater allowance. However, if the difference between dock water and salt water is this, we have a dock water allowance. So The change in the draft is directly proportional to change in density. Let me put it this way. So change in drafts is directly proportional to change in relative densities, RDs or densities. So well, I can write like this: dock water allowance divided by freshwater allowance is the change in density from dock water to salt water divided by change in density from fresh water to salt water. This one, change in the density. Or simply I can write like this: density of salt water or RD of salt water minus RD of dock water divided by RD of salt water minus RD of fresh water. Well, it is the difference. So whether I subtract from fresh water to salt water or from salt water to fresh water, it is going to remain the same. So RD of salt water, we know it very well. It is 1.025. And RD of dock water has to be between fresh water and salt water. Divided by, now this part which is RD salt water is going to be 1.025 and fresh water we know which is 1. So this gives me a relationship that 1.025 minus RD dock water divided by 0.025 is going to be dock water allowance divided by fresh water allowance. Now all I have to do, I just need to bring fresh water on right hand side. So I may write like this: dock water allowance is equal to 1.025 minus RD dock water divided by 0.025 multiplied by fresh water allowance. And this is a very useful formula. Just let me mark this. We can also use this formula if I multiply both the sides by 1000, like this: 1025 minus RD dock water in the multiple of 1000 divided by 25 for easy reference, multiplied by fresh water allowance. So this is a dock water allowance. Well, dock water allowance is nothing but change in the draft. So sometime I may write the formula like this: change in the draft is equal to change in the densities, change in relative densities divided by 25 or 0.025 multiplied by fresh water allowance. And this change in the densities is in multiple of 1000. So let us understand this problem, that a vessel of freshwater allowance 200 mm goes from water of RD 1.018 to water of RD 1.006. So vessel goes from this water to this water. Find the change in draft. So we need to find the change in draft. Well, we have just calculated this. The change in draft is going to be change of RD divided by 25 multiplied by fresh water allowance. So now change of RD is 1018 to 1006, and then I can multiply it by 1000. So 1018 minus 1006 is going to be 12 only. So I use this 12 divided by 25 multiplied by fresh water allowance, which is 200. So I get this 96 mm. Well, this fresh water allowance was also given in mm, 200 mm. So what happened? Since the RD of water has decreased, the vessel has gone from high density, let me just scroll it up to make it more clear, from high density to low density. If the low density will not be able to support, the vessel will sink, and if the vessel will sink, the draft will increase. So the draft will increase, and that explains the application of this formula.